Ready to roll, so I'm going to get started here. Today we're talking about DC wiring and boss cabinets. So really how to wire together our products on the DC side of things, how to make those battery to battery connections or battery to inverter connections, when to use a combiner, what size cabling do you need overcurrent protection, what types of overcurrent protection are okay to use, etc. We're going to get into some details today and give some examples on specific wire sizing. If you have a question, be sure to pop it into the Q&A bar at the top or bottom of your screen, depending on your layout. I will try to pause immediately and answer your questions, but if not, I'll definitely get to all of them at the end of the presentation. Really excited to get into this stuff today, guys. This is going to jump right into our content. We're not going to mess around today, so stay tuned. All right. So without further ado, let's talk about DC wiring methods. This is what I would say an incorrect example, or maybe just not the recommended method if you can avoid it. With our standard line of products, we do not allow this wiring method. If you're using our indoor rated Phi or SimpliPhi batteries, this is not going to be allowed. And here's why. Does anyone guess, what issues this would cause? Let me know in the Q&A if you can guess what issues this would cause. So this would cause imbalancing, right? So it's not symmetrical as you look at it, and that means that it's not symmetrical electrically speaking either. So this battery that's closest to the inverter has the least resistance. So it's going to, electrical currents want to take the path of least resistance. Great, I see some great answers. The first battery gets more amperage coming off the same end of the batteries for the positive and negative. That's absolutely correct. If you had to wire it this way and you had no other way of doing it, you should at least take the negative cable and run it off this negative other end here on the left side to a little better balance the batteries. So again, there's more resistance on this battery on the leftmost side because it's got more cable distance to travel through before reaching the inverter. So what would happen if you did wire the bank this way? And we all know that lead acid batteries are commonly wired in this way. It's not really a major issue with lead acid. Let's look at what would happen here. What would happen is the voltage would kind of have a cascading drop. So you'd see more current being provided by this first battery in the bank, and then the current being provided by each battery would drop as you move down the line. And because of that, there's also a voltage drop, that cascades as you go down the line. So this is not recommended for SimpliPhi batteries, not recommended really for any lithium batteries if you can avoid it. It's very dependent on cable size too. So if you had a 6 or 8 gauge cable pumping 50 amps, you'd see pretty realistically these numbers here is probably what you'd see. Whereas if you had a 4/0 cable connecting these batteries and a really nice flat connection on any of the lugs that are overlaid on top of each other, then this cascading effect would be almost non-existent. So it's variable. And with lead acid batteries, why is this not a big deal? Can anyone tell me why this is not a huge problem with lead acid batteries? Lower float voltages? No, I wouldn't say that's why. The reason this is not really a problem with lead acid batteries is because between 55 and 54.5 volts, that's a 1 volt difference in the voltage of the entire bank. So with lead acid, they have a wide voltage operating range, and that 1 volt difference, that might correlate to, let's see, 20 to 25% state of charge. That is important. Excuse me, I'm misspoken here. That correlates to 10 to 15% state of charge for a 1 volt difference across the bank. Now that's important, but it's not going to destroy a bank quickly. It's not going to wear extremely unevenly. Whereas with a lithium battery bank, a 1 volt difference is up to 70% state of charge here. So we can look at, at the 20% depth of discharge mark, we see that voltage around 57 volts, and then all the way until the 80% depth of discharge mark is when it finally reaches 56. So that's a 60% state of charge difference across the bank with a 1 volt drop there. So that's something to keep in mind, is there's a much greater difference in state of charge across a lithium bank differing 1 volt as opposed to a lead acid bank differing 1 volt. That 1 volt correlates to 10% state of charge on lead acid or 60% state of charge difference on lithium ion. This is real data from our batteries. There's more accurate data from our actual batteries is a discharge test here. And so you can see, let's look at this middle line, the C/3 discharge rate. At 10% state of charge, we're at 52.5 volts, and we don't drop to 51.5 volts until we're at 70% state of charge, or excuse me, 70% discharged. That means there's a 60% difference in state of charge for that 1 volt drop across the bank. So going back to our example here, you could have this battery bank charging up to 100%, and maybe this one is only reaching 40%, and vice versa. This is going to discharge down to 40% before this one may even begin to discharge, too heavily at all. So that could be a major issue if you're using small cables and daisy chaining your batteries. So do not do this. We're going to talk about correct methods now. This is an approved and correct method for wiring lithium batteries. This means that each individual battery unit has their own home run cables directly to a combiner, box, or bus bar. And then the inverter, charger, and the MPPT charge controller and any other loads are going to pull power and push power right to that combiner or bus bar, that same place that the batteries are landing. Now, the reason this is acceptable is that you will have each battery seeing the same voltage and same amperage. Just think about the symmetry here. So even if you do have a small voltage drop, maybe you see 56 right at the inverter charger and 55.5 here at the bus bars, that's not a problem. At least in this case, each battery is seeing that half volt drop. That's pretty common. We see that all the time. And people say, hey, my battery bank isn't actually reaching 56 volts. I would say just increase the absorb time a little bit, little by little, until you see them reaching 56 volts for a slight amount of time. Maybe if going from 6-minute absorb to 12-minute absorb, or 18 minutes, etc. This is another approved wiring method. So this can involve using a bus bar and mounting it directly to the terminals of the battery bank. So you'd either order a custom bus bar, you could buy one from us for 2 to 3 battery kits, or you can even manufacture your own if you've got something like a CNC or drill press. Now, each group of batteries, if you're doing this for a large system, let's say you've got 80 batteries in a system, and you want to use terminal bus bars on 10 batteries at a time, then you'll have 8 groups of 10. Now do me a favor here, do not group one group of 5 and one group of 4 and one group of 6, 7. Just group them all with the same number of batteries, and then they'll be very well balanced. When you're doing this, you do need to make sure the bus bar is rated to handle the continuous current that the batteries can provide. So in this case, each battery can provide 37.5 amps. If you had 10 batteries per group, that's 375 amps per bus bar that the bus bar needs to be able to handle. Your jurisdiction may require some additional overcurrent protection on any wires going from this bus bar to some sort of combiner. So just keep that in mind. Like, each battery has an 80 amp breaker. But if you've got 10 batteries in a group and they're not actually going to be carrying 80 amps at any time, then your wire shouldn't have to be able to handle 800 amps. You may want to downsize that wire, and in that case, you would need some overcurrent protection. So keep that in mind, and we'll talk a little bit more in detail about overcurrent protection as we move forward. Looks like I skipped my introduction. Thank you, Benito. My name is Matthew Walker. I am our IQ support and training coordinator here at SimpliPhi Power. Thanks for tuning in. All right. See a couple other specific questions. I'm going to get to those at the end. Bus bars and combiners. So when you do need to use a bus bar or a combiner, as you see in this photo here, in the center of the screen, you'd use a bus bar or a combiner there. When you do need to use them, here's some suggestions of products I recommend. Firstly, to reduce the number of cables, check out our BB-2 or BB-3 bus bar kits. This is what you see in the middle of your screen here, combining 3 batteries in our BOSS cabinet. If you were combining 250 amps or less, there is a midnight combiner box with a disconnect built in. This is really convenient to have a DC disconnect. So this is, again, for only 250 amps of current or less. That is the MNLBC-W250. If you're combining up to 1,000 amps, we have an outdoor rated cabinet that is UL certified that can provide 1,000 amps of continuous current flow, and it's got many cable mounting points. It's just a BOSS 6 cabinet with some big beefy bus bars built inside of it. If that's not in your budget range, or you're not in need of a large outdoor rated cabinet, 2 other options are the Midnight MNBCB 1050. This is a large combiner that handles 1,000 amps, but it is a little bit more budget friendly than our BOSS cabinet, and it is indoor rated only. We've also got we also recommend the Victron Lynx system. There's a distributor or a power in. The distributor is able to be fused for overcurrent protection, which is really convenient. The power in is not able to add fuses, but that's fine because our batteries have built-in breakers. So maybe you don't need fusing. That is a great system. Now these Victron Energy combiners, they have 4 connections each, but they can be stacked in parallel. So each unit handles 1,000 amps. So if you stack, 10 of them in parallel, you've got 40 connections and 1,000 amp rated combiner. So that is a really good option. Indoor rated here, that's not outdoor rated. And if you've got over 1,000 amps, you really only have 2 options as far as I'm aware. You can get Storm Power Components to custom manufacture something just for you. They do a great job. Or if you need something, to up to 2,000 amps, we've got a BOSS combiner that is, again, a BOSS cabinet with very, very large bus bars. Now we've got an even larger bus bar rated for 2,000 amps. So that's an option too. It's kind of a custom order thing, so let us know if you're in need of that. All right, moving forward here, I want to talk about how to connect wires or bus bars to the batteries. The cable lug or bus bar is going to be the first thing that touches that terminal post on the battery. So there should be no washers, no lock washers underneath of that current carrying material. That's just going to add extra resistance. It's going to cause heat to be generated at that point. So what you're going to do is just place that battery cable lug directly onto the battery terminal, nice and flat connection there. Or you can use the bus bar direct to terminal. And then on top of that battery cable lug or bus bar goes your flat washer and your lock washer, and then finally your nut. And make sure to torque this nut to 13.3 foot-pounds, which is equivalent to 160 inch-pounds. So use a torque wrench and don't just use an impact gun or a socket wrench. I have personally seen people damage the threads or even completely just, rip the terminal right in half with their socket wrench by going as hard as they could for some wild reason. Make sure you're using a torque wrench or even just using a little common sense and just going a bit lighter than you usually would if you don't have your torque wrench on site. Any damage caused by over torquing is not going to be covered by our warranty. So those are unfortunately an annoying little repair that would have to be made. All right, so let's talk a little bit about conductor sizing. Conductor sizing, I'm sure I'm going to be debated heavily on this, so please chime in. So steps to design a DC battery system. First, you're going to determine the maximum continuous load and amperage from the entire battery bank to the charger or the loads. Then from there, you'll divide it up into each wire. So if you've got 3 wires, it's a set of maybe 2 positives and 2 negatives going to that combiner before they reach the load. Make sure then you divide the total current in half because each wire is only carrying half of that current. Then you're going to determine the absolute minimum required size as far as the code goes so that you pass inspection and prevent overheating. And then from there, you're going to determine if you want to upsize your run to make it a more efficient and well-performing system. So I'm going to get really specific here. Let's look at this example. Now, I know the wiring looks crazy, but you've got 6 equal length, equal gauge cables here. And you've got a SolArc 12K unit. So we know that the SolArc 12K has a maximum battery charge and discharge amperage of 185 amps DC. We're then going to divide that by 6 batteries, each sharing that current. So they're providing up to 31 amps each. And then we're going to look at the NEC minimum required size. This is the first thing. If you're using a bus bar or cable, this is the minimum size. So we said we had 31 amps per battery. So that's a minimum of 8 gauge here. If you are going for the 60 degrees Celsius rating, if you've got a 60 degrees Celsius rated conductor, if you've got a 75 or a 90 degree rated conductor, then you can go up to 10 gauge. I really would not recommend that. Would never recommend a 10 gauge wire with our batteries, but I guess technically you could use it. I would always go with at least 4 gauge just to make the system efficient. But here's where we're going to talk about upsizing. So note that your minimum, depending on your wire's temperature rating, is between 10 and 8 gauge for your absolute minimum for the battery wire going between the battery and the combiner. We're talking about these wires here, the smaller ones. The inverter wire is actually going to require a 4 gauge minimum. So that's going to handle all 185 amps here on these large red and black cables. So going back to the NEC requirements, 185 amps, that looks like it's a 4-aught, or if you've got a 75 or 90 degrees Celsius rated cable, maybe a 3-aught. But at that point, we're going to talk about upsizing. So you know you need at least a minimum of 3 to 4-aught and 8 to 10 gauge, depending on your temperature rating. And then you're going to upsize if you want to make things more efficient. So this is a great resource here, this DC wiring resource by Blue Sea Systems, this chart here. So if you've got 185 amps, you can look at the length of your run and use the 200 amp category here. So let's say you had a 15-foot run. Now that includes both your red and black cable. So if you've got a 7.5-foot red, 7.5-foot black, that's a 15-foot run. You're going to take the 15-foot critical voltage drop. You want to make sure there's no more than a 3% voltage drop on any one wire, and go over to the category of 200 amps and note that you could get away with a 2-aught wire to avoid that 3% voltage drop. So that would be fine. Then you can use the NEC minimum of 4-aught. But if you realize, oh shoot, I have over a 50-foot run, which really you should never have, but if you do, then you're going to need larger than a 4-aught cable, and you're going to need to upsize from there. Now, same thing for the battery wires, 30 amps. We said there were 31 amps, so we'll go with the 40 amp section. And let's say you have a 25-foot run. So you got a 12.5-foot red, 12.5-foot black. That means you should upsize to a 4 gauge to make this more efficient, to avoid a large voltage drop between the combiner and the batteries. So upsizing on your battery wires would be required in that system. And I will include these links in the follow-up email that gets sent out after we're done. Any questions there? Robert, we are going to do this with 3 different bus bars and groups of batteries. Will that void the warranty? No. Make sure that each of your group of batteries has the same number of batteries in that group, such as 3 groups of 3. Make sure that all the conductors are rated to handle the continuous current they're going to see. And make sure that all the wires, again, between the batteries and the combiners are the same length and same gauge. What's your recommendation for wiring an Outback to a Boss 12? I'm not sure what recommendation are you looking for? A wire size, a specific product? Again, it's going to be very similar to the example we just saw. That's a great point there. Heat is just wasted energy. So always upsize. I see you have a 100-foot run from home service and back to inverter at a farmhouse project. That's a long run. Is that the AC run or the DC run though? Because if that's between the batteries and inverter, that makes very little sense. But if you've got an AC run of 100 foot, that makes total sense and it's not really a problem. AC, great. A lot less energy loss there. Good point here from Benito. She's got 2 Boss cabinets to combine 24 batteries. So that we're going to talk about here in a minute. Boss cabinets, just skipping forward here, Boss cabinets are a great product to combine large numbers of batteries. They can handle 650 amps continuous current here on these terminal blocks, and recommended to purchase with them is these BB-3 kits, the bus bar kits. this is a very stylish and neat and well-balanced way to combine all your batteries. And then from here, from this combiner block, you can either go straight to the inverter, or if you've got multiple boss cabinets, you may need another combiner as well. All right, so let's go back here. Where was I? Was right here. All right, so instead of using this method, you can also choose to use this method. So it's the same number of 6 batteries and 1 inverter. In this case, you're combining a group of 3 batteries onto a bus bar and another group of 3 batteries onto a bus bar. So great. This is maybe what I recommend for your example. Have your 12 batteries in groups of 3, and then landing them on a combiner before taking them to the inverter. In this case, you're looking at 93 amps per wire going between the batteries and the combiner, since there's now 3 batteries per group. So just another example of a different way that you can do it. There's a million ways to wire these systems. It's always a puzzle. All right, so now let's talk about overcurrent protection. I'm not going to necessarily talk about when you need it. That's kind of up to you to decide, but I'm going to talk about what types to use and what size to use. Remember that not all overcurrent protection is the same. A 50 amp rating on your overcurrent protection, whether that be a fuse or a breaker, it doesn't mean that it opens the circuit at exactly 50 amps the second it sees 50 amps. It might not open circuit until it's reached 65 amps, for example, and until it's seen that 65 amps for 10 seconds. You don't know until you look at the trip curve. Also, do not use AC rated disconnects of any type, switches, fuses, breakers, disconnects. Do not use any type of disconnect for an AC that is not rated for DC. So if you're on a DC system, you should be using only DC rated disconnects. The reason for this is that AC breakers do not have any sort of magnet to suck out an arc, and they may not be rated to handle the proper voltage in the circuit. So in an alternating current circuit, that switch or breaker is going to use the point of no current to extinguish the arc. Whereas a direct current system doesn't have a point of no current. There's always current flowing in that one direction. So the breaker or disconnect needs to have a magnet to suck out the arc, to extinguish that arc from causing a fire. So that's why you cannot use AC breakers on a DC circuit. You also want to ensure that your fuse or breaker is rated to handle the highest voltage present in the circuit. Now, I would even get really picky on this. Your inspector is going to call you out if you have a breaker rated to handle up to 48 volts and your system max charging voltage is 56 volts. So make sure it's able to handle the maximum voltage. Just reviewing the questions here. Don't worry, Dana, I will send out a recording of this so you can review the slides as long as you need. All right, so let's talk now about some specifics as far as current ratings, but I just want to stress one more time, do not use an AC rated disconnect on a DC circuit of any type. That could definitely end up causing a fire. Now, we're looking at a system where, let's say you need overcurrent protection, and you're looking at this 60 amp rated breaker. Now, note that on its trip curve provided by Blue Sea Systems, we're going to see that it does not blow until it's about 110% of its rated current. So that'd be 66 amps, and it takes it about 500 seconds to do that. So this is why it's misleading. It's a 60 amp breaker, but it doesn't open immediately at 60 amps. It takes almost 10 minutes to open at 66 amps, or 10 seconds to open at 120 amps here. So it doesn't mean it's not performing as it should. It's doing exactly as it should, but it can be confusing. So you need to look into this stuff. This is a different product, a different DC breaker. It's rated to open the circuit after 5 seconds of seeing exactly 100% of the rated current value. I'm not sure exactly how it does this. That's pretty impressive. Now let's look at some other breakers here. This is a fuse. This is a different type of disconnect here. This is going to blow at about 140% of its rated current in about 20 seconds. So about 80 to 90 amps, and it's going to blow in 10 seconds. As opposed to maybe what you think you're getting is something that blows at 60 amps in something like a 1/10 of a second. That is not how they work, which is interesting, to find out. This is why I don't recommend using overcurrent protection to limit battery charge and discharge current. I always recommend simply sizing the battery system properly to match the charge and discharge current of the inverters and charge controllers, so that you're not relying on a fuse or breaker. You know that the batteries can handle everything the system can throw at it. Now our battery even has a 100 amp breaker built in. This is our Phi battery, our SimpliPhi battery, and even our new outdoor rated ESS. They all have a 100 amp breaker built into them. And they also have a 10-minute surge of up to 100 amps. So this is the only overcurrent protection you need. It depends on your jurisdiction and your wiring layout and the size of the wires you use. So keep in mind that this is here for your convenience and it makes for an easy installation, but you might need something additional as well for protection of other wires. I want to point out that breakers and fuses don't do a whole lot to protect appliances or batteries or inverters. It's really more to protect the wires. That's the main purpose that they serve. All right, I want to touch on our products as well. We offer a 3.8 kilowatt hour battery. This is at 24 or 48 volts. You can buy it in either configuration. This is rated to charge and discharge at C/2, as with all of our products. So C being the capacity of the battery of 3.8 kilowatt hours, and dividing that in half to get 1.9 kilowatts of charge or discharge power continuously per unit. There's also a surge of up to 5.1 kilowatts per unit for 10 minutes. These are made for parallel connections only, and they have a 3/8 inch terminal post. You should not be daisy chaining these batteries as we saw in the beginning. These are made for only going from the battery to a common combiner unit. Same thing here. This is the same product, except now with a stronger and more intelligent BMS. So the previous product, this is a drop-in lead acid replacement. No user interface, so to speak, whereas this battery has communications with an inverter. It talks to the SolarArc or the SimpliPhi inverter or the Sunny Island, and it is a much more intelligent and strong battery management system. But as far as the charge and discharge specs and the kilowatt hour rating, they're all the same. 3.8 kilowatt hours per battery, 1.9 kilowatts of discharge per battery, and that scales up as you add more batteries to the bank. We've got our battery only storage system. Now somebody asked about the weight here. I don't have this on hand. I believe the larger unit is around 600 pounds and the smaller unit is around 300 pounds. I'll have to check on our website and get the exact weight for you. This is a NEMA 3R rated cabinet, so it's outdoor rated. It's been tested by UL to 9540 and 9540A standards. It comes with a 5-point terminal block already mounted in the cabinet. And what I would highly recommend is purchasing separately our BB-2 or BB-3 kits to combine groups of batteries into 2 or 3. We can also use this same cabinet, remove the batteries in the shelf, and sell this as a combiner. So what we'll do in that case is mount a large bus bar on the inside of the cabinet, and there are convenient knockouts for cables to go in and out of the cabinet on the side for conduit to connect there, and that serves as your system's combiner. So if you need that sort of a custom thing that we are building to order, not to order, but we're building it when you order it. So it's a little bit longer of a lead time, but that is available. Here's a great example of somebody who used our Boss cabinets in a basement. This is an awesome installation by Sun King Incorporated in Hawaii. So they're on our Elite IQ installer map. And if you're in Hawaii looking to get some work done, these guys are pros. They know how to use our products. They know how to make nice, clean systems. And if you want to get featured here as well, you can apply for our IQ program. I'm going to show you how to do that here in just a minute. Now, I wanted to mention our newest product as well and how wiring differs with this. So we've got a 6 kilowatt inverter, a 4.9 kilowatt hour battery, and an energy track control system to view and modify the system from your app. Now, we are actually allowing daisy chaining with this. I know I mentioned that's not a recommended method, but there are ways to mitigate the issues that it causes, right? So I said if you use 4-aught cable and if you minimize the number of batteries in a daisy chain, so we're allowing up to 4 batteries per daisy chain with 4-aught cable. And in our tests, this has caused no noticeable imbalances in the system as long as you make those nice flat connections between lugs and you're not using some, 8-gauge cable with the Home Depot lug crimped onto it. No, you're gonna use a 4-aught cable with a nice large flat connection on the cable lug. Now, this is still not the ideal method. The ideal method would be combining to a combiner for each battery having its own separate run to a combiner, as we talked about. But being that this is an outdoor rated system, outdoor rated combiners are quite frankly just difficult to find. So given that we don't want everyone fighting over them when they do, become available, we want to allow this configuration where you'd have, 4-aught cables daisy chaining and the red, cable going from one end and black cable coming from the other end to the inverter. That is allowed. Now, if you've got more than 4 batteries or more than 1 inverter, you will absolutely need a DC combiner to combine those strings or parallel strings of 4 batteries and then pulling power off of the same DC bus for both inverters. So you will absolutely need a combiner if you've got more than 4 batteries or more than 1 inverter. This is how that would look. The wiring with the Boss cabinets, good question there. So when you order a Boss cabinet, the only wire that's included is a 4-aught cable that goes from the Boss cabinet to the inverter. I don't know the length offhand, but we can check for that. The busbar kits come with their own wire, but you have to order the busbar kits separately from the Boss cabinet. So they do come with their wire. A full Boss 12 cabinet full of batteries, you're saying that is about a ton Let me check that. So we've got 12 batteries times 86 pounds per battery. That's 1,000 pounds plus 600 pounds for the cabinet. That's about 1,600 pounds per cabinet. So yeah, it's a very heavy cabinet once it's fully assembled, though it is shipped such that the cabinet is empty and the batteries are shipped separately so that we can keep them all safe during shipping and packaging. Good question here. Is there a fuse inside the 3.8-M battery? No, there is not. There is just a breaker, and the breaker is accessible by you, the user. So you can go at any time and turn the breaker off or on. All right, going to keep powering through here and finish up with the questions later. So as far as resources, just wanted to place them all here. This is the wiring guide that we have created. This goes through many examples of different ways to wire a battery bank, wiring diagrams that are very detailed, different products. Like for example, this is the Schneider PDP, and you can combine up to 4 batteries there. There are connections for inputs right there on the PDP. These are, some examples of the midnight combiners being used, different busbar methods, etc. So definitely check this out. There's even an example of how to size wires and conductors, just as I've talked about today in this wiring guide. This is on our website on the support tab, but I've linked it here for convenience. This is the DC wire gauge chart we looked at from Blue Sea Systems. This is the NEC ampacities charts. This is your absolute minimum ampacity. And then the Blue Sea one is what you're going to use to see if you need to size up for a longer run. You can also email me at training@simpliphipower.com. I will do my best to help each and every one of you. But also remember, you can reach out to sales@simpliphipower.com and they can help you design a system. Now, if you are in our Elite IQ Installer program already, you know about being on our map here. So this is what you'll get access to, be on our map here, visible to customers. So if you are looking to get more volume of installs completed, this is where we can place you and refer our customers to the nearest IQ installer. You can also make money from doing this. So each installation you do as a member of the IQ program, send us your warranty registration. Just submit your warranty registration on our website as you normally would, and we'll give you $25 cash back per battery install. We're also doing a photo contest. You do need to be in our IQ program to be eligible to win, and winners can get $250 a month. So make sure you sign up for our IQ program if you're already installing our products. It's a no-brainer way to make a little extra cash and get a little more business without really doing much work. It takes about 5 minutes to sign up. You can just email me or give me a call. Now, to get qualified as a SimpliPhi IQ installer, you can do one of 2 things. You can apply here, or you can email or call me. So call me at 805-640-6700, extension 425, and I'll get you through the program. 805-640-6700, extension 425, or email training@simpliphipower.com. All right, so I'm going to jump into the Q&A. Thank you for the kind words, Benita. I can't really speak to lead acid batteries, unfortunately, Glenn, but from what I can see here, I don't understand the benefit of leaving one battery off of the system. I would just put it on there and have that extra energy available all the time. The qualification that allowed for daisy chaining, that was if you're using our new SimpliPhi outdoor rated 4.9 kilowatt hour battery. That is the only product right now that we're allowing daisy chaining with, because it's outdoor rated. And outdoor rated combiners are quite hard to find. So this battery here is what we allow daisy chaining on, and it's only up to 4 batteries, and you have to use a 4-aught cable. You can of course still use the other methods we talked about, like direct bus bars or individual cables for each battery. How about if in 1 year after installation you decided to increase your system size? Would you need to change all the wiring? Great question. It does depend on the system. So let's go back and look here at one example. If you had this example and you simply added one more battery to the mix, you would not need to change any wiring as long as your combiner here could accommodate one additional positive and negative cable. If you added an inverter, however, and didn't add batteries for whatever reason, first off, I would not recommend that configuration with 2 inverters and only 6 batteries. But if you did do it anyway, you would need to rewire the batteries because they'd be pushing more power to the inverter. So that's just an example. So it kind of depends on your configuration. You kind of have to go through, if you add something to the system, go through and look at each wire and ask yourself, how much current is this providing? If you get a slightly larger inverter and now each battery is providing only 3 or 4 more amps, probably nothing changes. If you double your inverter size, then yeah, things are probably going to change. Unfortunately, you may have to rewire some connections, or if you're adding 10 batteries to the system, maybe your combiner box doesn't have enough terminal posts to accommodate all those connections. So yeah, keep that in mind. You may need to rewire some things. Yeah, that's a good point you brought up, Glenn, that there's a terminal lug in my image here. Let me go ahead. This is an old image. There is not actually a nut on the bottom of this terminal post. So that is no longer there, but I just cannot find a new image to replace it. So I apologize. That would not be ideal. What you actually see here nowadays is a flat washer, a flat copper washer, and there's no terminal nut here. Good point. 14.3, is that a question? What's the question there? All right, I'm going to go back to a slide, the steps to design a DC battery system. You know what your question was on this slide here? Here we go, steps to design a DC battery system. Here we go. Any questions on this, Dana? This will be available as a YouTube video, so we're going to email you all a link to the recording, and we'll include the links in the description. All right. Well, that looks like all the questions. Again, thank you all so much for joining. I look forward to seeing you next time. Hope I was able to teach you something. Hope you have a great rest of your day. Talk to you next time.